Welcome back, grade 12. Okay, so I'm just going to go through differentiating the repeated bracket functions. I'll just give an example of one. Let's say you got y is equals to 3, 5x squared minus 2x to the power 10. And you're asked to differentiate this. One of the best ways you can do this is to expand this first, using whatever methods, and then you take the result and then you differentiate it. And this could be, I think, a hell lot very long an approach. There's a simpler way to deal with this. So what I tend to do is I rewrite this as a general form. I say that the constant that is going to be outside, I'm going to call it a, and then the function that is inside, because this essentially is a function of x. Okay, this essentially is a function of x. I just call it f of x, like that. And then I call this power n. So the reason why I try to do this is because when it's usually taught, we normally put a linear function inside the bracket. But when the exam questions come, they don't just include a linear function, they can include something of the sort as I've placed in here, or even square rooted functions as well. So that's why I'd rather keep it as general as possible. And then when you get the simpler specific cases, you're able to adjust this method to any other type of a function. So here, the form of our dy dx is going to be, it's everything that you use to the first two procedures. So you bring your n down, so that's n dot, your a, okay? And then you still have everything just as you're used to. And then your n minus 1 being the second procedure. But then the only difference is you now multiply by the first derivative of the term in the brackets. So the only adjustment, so in other words, instead of having 2 steps in your procedure, you now have 3 steps. So the first step is bring down power. Notice how I'm not really saying the statement in full because I need it to be easy for you to remember. So bring down power. That's the first one, which is what we did there. And 2, it is lower power by 1, which is exactly what we did right here. And then the third step in the procedure is multiply by first derivative. Now notice the way that I wrote this. So when we want to talk about functions, dy dx, we say it is the first derivative. And how do we show this? Notice how I have this here. It's a sharp, or it looks like a 1. And that means that I've only differentiated once. So you could alternatively use differentiated once. So alternatively, if you want to write it like this, it's acceptable, or like that is acceptable. But then when you differentiate the same term twice, rather the same function twice, notice how we write the second derivative. It's not dy squared, it's d squared y over dx squared. So I think for now, just take it for granted why we write it like this. And how do we show it there? It's f prime prime. That means that I've differentiated twice. I'll give an example of how we differentiate twice. So if I was to do this a couple of times, then my other derivatives would be dny over dx to the n, which will be f as many sharps as I need of x. This is just notation that you need to get used to, which means that I differentiated, n times. Very important. Okay, so if I take my statement, let me see if I have a statement. Let's say I've got the statement y is equals to 3, 5x squared minus 2x to the 10. Okay, so like we say, the first procedure for my dy dx is to do what I did before, the first two procedures, bring my power down. So that will give me 10 dot, the 3. And I write everything as I usually would. Then my second procedure is to lower this by 1. And then the third procedure is to multiply by the derivative of what's inside. Now the derivative of what's inside is an application of what we did in the last video, where remember we bring this down and then we lower it by 1. Bring this down, lower it by 1. And you'll notice that we end up with a 2.5x to the 1 minus, because this is y is equal to 2x. That reminds you of the straight line that we spoke about. So it only gives you the constant there. And we end up with a statement like 30. This still remains the same. The only reason why we had this is now a 9 dot 10x minus 2. And this is how you present your answer. Or some may actually prefer to put this bracket here. The difference is the same. Like that. Okay? And I'll just give you another example. Just give another example. Y equals to, let's say, notice how it has to be a constant outside. 6, let me say minus 6. 3x to the power half minus 2 to the power minus 3 over 2. Now we're kind of switching and turning it up a bit. As per the usual, our dy dx, first things first, we're going to have to bring our power down. That gives us minus 3 over 2 dot the minus 6 that we see outside there. And the next procedure is just to repeat everything as is, and then we subtract 1. And then dot. Now inside there we have to bring the derivative of what's inside the bracket there. So when I differentiate this, minus 1. And we know that the derivative of a constant is 0. So that will give us a half dot 3 x to the power a half minus 1. That would essentially give us 3 over 2 x to the power minus a half. Minus 0, if you will. So this is our derivative of what's inside there. That's essentially what we're going to put in there. 3 over 2 x to the minus half. And the final is going to be the minus 3 over 2. Okay, this 3 over 2. And then I'm going to bring this term in there. That's going to give us 3 over 2 x to the minus half. And then we still have our minus 6. And then 3x to the half minus 2. And then notice how this is going to become a minus 5 over 2. And after simplifying this, I'm supposed to get, after simplifying this 2, I'm supposed to get minus 9 over 4 x to the minus half. Okay, so that's what I'm going to multiply with this here, and that would essentially give us a plus 30. Okay, let me not jump anything. Let me just show you everything as it is. 9 and 6 is 54, so that gives us a plus 54 over 4 x to the minus half 3x to the half minus 2 to the minus 5 over 2. It looks a bit complicated because we involved fractions, and as we all know, fractions kind of do make people very uncomfortable, but you will have to make sure that you master those and you get used to them here. So this is a form, if you want, you can write your answer, or you could actually lower it there. If the 4 could go into 54, that will give you a very easy answer. But in this case, I think the least you can get is like a 27 over 2 or something. But writing as a decimal isn't really advisable. You just keep it as it is as a fraction. Because when it comes to your matric maths, as far as I'm personally concerned, negative numbers and fractions, which are the things that people avoid the most, are really very powerful. The more you get accustomed to using them and being comfortable with them, you will notice that your whole career through your matric year becomes very, very easy to handle. So our solution is that, or with the 27 over 2, whichever you prefer. And that's our final solution. So if you have any questions, please just go ahead and post them and ask, and I will be able to respond to you. Enjoy the rest of your day. Goodbye.